Hey there. Let's dim the lights. Take a deep breath. You're about to witness the beginning of everything. Not just life. Not just Earth. But the very first tick of time on this blue marble we now call home. Now close your eyes, if you like. We're drifting back. Way, way back. Roughly 5 billion years ago. Which, if time were a 24-hour clock, we're still not even at midnight yet. We're somewhere in the negative time zone, the cosmic loading screen, if you will. Welcome to the chaos. Picture the early solar system. Except don't picture planets, trees, or cozy oceans. Nope. It's chaos, total cosmic mayhem. There's no Earth. No moon. Just a giant swirling mess of dust, gas, and rock bits doing ballet around a baby star, our sun. The sun's only just finished forming from a collapsing cloud of hydrogen. Still glowing with the pride of being born. And around it? A violent cosmic disk spinning with millions of pieces of stuff, all bumping, smashing, sticking, and exploding. Imagine glitter in a blender. Now set the blender on fire. That's space right now. Tiny pebbles become a planet. Now let's zoom in. In all this mess, some little clumps of dust start sticking together, and when those clumps crash into other clumps, they get bigger. And bigger. And more dangerous. Eventually, one of those clumps wins the cosmic battle. It gets so big, gravity starts pulling more and more stuff into it. Like a cosmic vacuum cleaner. Congratulations, you're looking at Proto-Earth. Not the green and blue globe you know today. This version of Earth is a ball of molten lava. A glowing, spinning fireball. Definitely not vacation ready. A hot, angry newborn. Everything about baby Earth is unstable. The surface is just liquid rock. Temperatures? Think pizza oven. On steroids, atmosphere? Toxic gases and steam clouds. Not breathable. Not cozy. You wouldn't last a second. And honestly, neither would your shoes. But hey, every planet has an awkward phase. Back then, Earth was still being hit constantly by leftover space debris. Big rocks. Small rocks. Planet-sized rocks. One particular collision, though, was different. Enter Theia, the crash that made our moon roughly 100 million years into Earth's wild childhood. Something huge shows up. A planet the size of Mars. Its name? Theia. And Theia doesn't come to visit. It comes to slam right into Earth. Head on, full speed. A slow-motion disaster of cosmic proportions. The impact is so intense, it rips apart both Theia and a chunk of Earth. Molten debris goes flying into space. Not a few rocks, a whole planetary buffet of broken pieces. But here's the twist, those pieces don't just float away. They start to spin around Earth. Pulled by gravity. Clumping. Merging. And from that spinning chaos comes the moon. Yes. Our moon. Born from the ruins of a planetary fender bender. Why the moon matters now. You might think the moon is just a nice nightlight in the sky. But it's so much more than that. It helps stabilize Earth's spin. It gives us tides. It kept Earth from wobbling like a drunk toddler. Without the moon, life may never have had a chance. So yeah, hats off to Theia for taking one for the team. Still no continents, still no life after the impact. Earth doesn't calm down right away. Nah, it throws a tantrum for millions of years. The surface remains hot and molten. Volcanoes constantly erupt. Magma oozes everywhere. No oceans. No continents. No birds, bees, or bacteria. Just lava, lightning, and loneliness. But slowly, things begin to shift. The surface starts to cool down, just enough for crust to form. Like the skin on hot soup. Not stable, not pretty, but it's a start. Steam begins to condense in the sky. And after millions of years of relentless rain, we're talking non-stop stormy vibes. Earth gets its first oceans. Imagine it, the first time rain falls on land, and there's finally land cool enough for it to stick. Water, water everywhere, but from where? Now, here's a mystery. Where did all this water come from? One theory says Earth always had it, locked inside rocks. Another says icy comets brought it during those early bombardments. Maybe both. Either way, without water, we don't get life. Without life, no bedtime story. The calm before the spark, so now we've got a planet. Hot, messy, but real. We've got a moon. We've got crust. We've got oceans. It's still dangerous. Still unpredictable. But the pieces are falling into place. All Earth needs now is a spark. And that, dear listener, is where we'll pause. You've just witnessed the wild birth of our planet. From stardust, to a fiery sphere, to a cooling, ocean-covered world, we've still got billions of years to go. But for now, close your eyes. Let the sounds of crashing planets and swirling dust fade away. Earth is here. The clock has started. And history has officially begun. Last time, Earth was born in fire and fury. A swirling mess of lava, smoke, and attitude. Now, we're stepping into one of the darkest, most intense chapters in our planet's story. Scientists call it the Hadean Aeon, named after Hades, the ancient Greek underworld. And honestly, that name fits perfectly. Because Earth was basically hell at this point. A world you'd never survive. Let's imagine you had a time machine. You go back to this era, maybe to check out the early days. The moment you step out, boom. You're toast. No oxygen to breathe. No solid ground to stand on. No blue skies. Just choking gases, molten rock, and meteor showers the size of skyscrapers. Even your time machine would probably melt. So yeah, maybe don't visit this phase in person. The sky wasn't blue, it was blood red. The atmosphere back then wasn't full of fresh air. It was more like a toxic smoothie made of carbon dioxide, methane, ammonia, and steam. And the color? Forget those clear blue skies we know today. The Hadean sky was dark, red, and heavy. Like a storm that never ends. Lightning crackled non-stop. Clouds oozed chemicals. Raindrops were probably acidic. Romantic, right? Surface of fire, no place to chill. Earth's surface was still trying to cool down after the moon-forming impact. But it wasn't cooling fast enough. Lava flowed freely across the land, like bright orange rivers of doom. The ground was unstable. Volcanoes were everywhere. Tectonic plates hadn't even formed yet. Earth was still figuring out how to be a planet. And beneath all that chaos, the core of the Earth was forming, hot, molten metal sinking inward, creating the magnetic field we rely on today. But at the time, it was just more heat. More pressure. More madness. Space rocks, still raining down. You'd think the universe would take a break after smashing Earth with Theia, right? Wrong. The bombardment continued. For hundreds of millions of years, Earth was constantly hit by asteroids and comets. Some were small. Some were city-sized. All of them added more fire, more destruction, more chaos. One moment, peace. Next moment, boom. Crater, firestorm. Tsunami of lava. They call this the Late Heavy Bombardment. It sounds like a video game. But it was very, very real. And honestly, it's a miracle anything survived. A tiny hint of calm, but, eventually, something started to change. Earth began to cool. Very slowly. Like soup that's too hot to sip, you just leave it there, and wait. Over millions of years, the surface began to harden. The lava started forming crust, not exactly stable, but better than boiling goo. Some researchers believe the first bits of land may have appeared here, tiny islands of solid rock rising out of the fiery oceans. They wouldn't last long. But they were the first hint of what would one day become continents. Water, the ultimate game changer. Now let's talk about water again. At some point during the Hadean Eon, oceans began to form. Where did the water come from? There are two main ideas. 1. Volcanoes released steam trapped inside the earth, which then condensed into rain. 2. Icy comets slammed into Earth, delivering frozen water from deep space. Either way, it rained. A lot. Like, millions of years of non-stop rain. Eventually, this endless rain filled the lowest parts of the crust, creating the first oceans. Not the clear blue Caribbean kind. More like hot, acidic soup with a side of sulfur. Still, it was water. And that changed everything. No oxygen, no life, yet now you might be wondering, was there life yet? Nope. Not even bacteria. The Earth was still far too unstable. Temperatures were extreme. Radiation levels were high, no ozone layer to protect anything. But something interesting was happening. In deep ocean trenches, around hydrothermal vents, chemistry experiments were beginning. Hot water, minerals, and pressure created the perfect environment for pre-life reactions. It wasn't life yet. But it was close. Like the ingredients of a recipe, before they're cooked. Tiny hints buried in ancient crystals. So how do we know what Earth was like back then? Good question. It's not like anyone wrote it down. But scientists have found tiny crystals, called zircons, that are over 4.3 billion years old. They're like time capsules, little snapshots from a hellish Earth. Inside them, clues about ancient water. Hints of crust, even whispers of stable temperatures, buried in the chaos. It's incredible that something so small could survive this long. Especially on a planet that tried to melt everything. Why this chapter matters? You might think, okay, cool, lots of lava and bad weather. Why does this matter? Because this chapter is the setup. The hardest level. The opening act that made everything else possible. Without this era, without the chaos, the cooling, the comets, the crust, and the oceans, life would never have had a stage to perform on. Sometimes, the darkest parts of history are the ones that carry the most weight. Take a deep breath. Let's pause for a moment. Close your eyes. Picture Earth as it was, a glowing red planet. No trees. No birds. Just fire, smoke, and the endless sound of volcanic thunder. And yet, somehow, it's preparing for life. You can't see it yet. But it's coming. The nightmare is almost over. And the dream is about to begin. We just survived the most violent era in Earth's history, the Hadean Eon. Fire, lava, meteor showers, acid rain. Honestly, if Earth were a hotel back then, the reviews would have been terrible. But now, things are starting to shift. The year is around 4 billion years ago. Earth is still wild, still dangerous, but it's finally learning how to breathe. Welcome to the Archean Eon. It's the beginning of something new. The beginning of something alive. The ground beneath our feet. Let's start from the surface. Earth's molten skin has finally cooled enough to become a solid crust. Still fragile. Still cracking. But it's there. Volcanoes are still busy, of course, burping out lava like they're in a chili eating contest. But instead of drowning everything, now the lava cools and adds new land. For the first time, the Earth has a real surface. Rocky, broken, and not exactly luxury real estate, but it's something. These rocky patches slowly begin to form the very first continents, or at least, their grandparents. They're called cratons, thick slabs of ancient crust. Some of them are still around today, deep under places like Canada, Australia, and Africa. Imagine that, standing on land that's billions of years old. The first oceans settle in the oceans, meanwhile, have grown deeper and wider. They're still warm. Still murky. Still filled with metals and gases. But they're everywhere now, covering most of the planet. And unlike the lava-soaked surfaces of the past, these waters are calm. Peaceful. Steamy. Quiet. The kind of place where something unexpected might begin. In the deep, something stirs down at the bottom of these ancient oceans, something weird is happening. Around cracks in the seafloor, hydrothermal vents pump out hot, mineral-rich water. Now, it's not the kind of place you'd expect anything to survive. It's pitch black. It's boiling hot. It smells like sulfur and metal. But somehow, life begins. Not fish. Not plants. Not anything you can see with the naked eye. But microbes. Tiny, tiny living things. Simple, single-celled organisms that feed on chemicals. No sunlight. No oxygen. Just pure chemistry. And yet, these tiny pioneers are about to change everything. The first life on Earth, these little microbes are called prokaryotes. Basically, bacteria without a fancy nucleus. They're small. They're simple, but they're unstoppable. They multiply fast. They can live in hot, cold, acidic, salty, you name it. They don't need oxygen. They don't care about light. They just do their thing, survive. Some of them might have been like thermophiles, heat-loving bugs. Others may have started figuring out how to use sunlight, chemicals, or even just iron in the water. It wasn't flashy. It wasn't fast. But it was life. The very first life. The Earth breathes life. Quietly think about this for a second. Earth has gone from being a molten, lifeless rock, to a planet with oceans, land, and actual living things swimming in the dark. And nobody's watching. There's no one to write it down. No dinosaurs. No mammals. No humans. Just billions of tiny, unseen lives, floating in ancient waters, replicating quietly. It's not a revolution. It's a whisper. And that whisper will become a roar. A day on Archean Earth. Let's say you somehow visited Earth around 3.8 billion years ago. What would you see? Well, first, you'd need a space suit. The air isn't breathable. There's no oxygen yet. The sky might look orange or hazy, filled with volcanic gases. The land is mostly barren, black rocks, sharp coastlines, no grass, no trees. Just volcanic plains and silent shores. But look closer at the ocean surface, and you might see something strange. A thin green film. Microbial mats, huge colonies of tiny life forms, floating and bubbling. No birds, no bugs, no noise. Just the wind, the waves, and the slow, secret rhythm of life beginning. Earth's first recycling crew. Some of these early microbes were chemoautotrophs, life that eats chemicals. Others, later on, began using a new trick, photosynthesis. But not the kind you learned in school. This early version used hydrogen or sulfur, not water. So instead of releasing oxygen, they released sulfur or other nasty stuff. Think of it as practice. Photosynthesis 1.0, the beta version. But it worked. It captured energy. It made life more efficient. Earth was still dangerous. Still unstable. But now, it had a working life support system. The long game. The Archean Eon lasted a long time, over 1.5 billion years. That's a huge chunk of Earth's timeline, but for most of it, the world stayed pretty simple. No animals. No plants. No drama. Just tiny cells doing their microscopic thing. It sounds boring. But in reality, this was one of the most important times in history. Because during this time, DNA evolved, cells learned to reproduce, microbes spread to every corner of the ocean, and most importantly, Earth's chemistry started changing. The setup for oxygen. As time passed, some clever microbes, cyanobacteria, began to evolve. They were the first life forms to use sunlight and water in photosynthesis, releasing oxygen as waste. At first, it was just a little. Not enough to matter. But they kept going. And going. And going. Until one day, the oxygen started to build up. But that's a story for the next chapter. From chaos to calm. Let's recap for a second. We started with a molten world, no solid ground, no oceans, no life. Now we have stable crust, global oceans, ancient continents, and life, tiny, invisible life. But life, nonetheless. And it all began here, during the Archean Eon. The world isn't perfect yet. But it's no longer just a rock. It's alive. Now rest easy. Close your eyes. Picture Earth, quiet and strange. No highways. No cities. No songs. Just dark oceans. Early continents. And billions of tiny cells, pulsing in the deep. They don't know what's coming. Ice ages. Asteroids. Dinosaurs. Wi-Fi. They're just surviving. And in doing so, they're making everything else possible. The calm after chaos is here. But don't get too comfy. The next chapter? Things are about to get toxic. When we last left off, Earth had just entered its chill era, oceans were calm, the crust had hardened, and life had arrived. Tiny, microscopic life. No drama, no noise, just little cells doing their thing underwater. But now? Now something's about to happen that will literally change the entire planet. And it all starts with some bacteria that figured out how to make food from sunlight. Seems simple, right? Well, it wasn't. And Earth? It's about to get a major makeover, whether it wants one or not. Tiny bugs with big plans, so let's set the stage. It's about 3.5 billion years ago. Earth is quiet. No trees. No fish. No dinosaurs. Just oceans and rocks, and those ancient microbes floating around like they're on a slow-motion spa day. Now some of these microbes, we call them cyanobacteria, start pulling off a genius move. They invent a new kind of photosynthesis. Not the early kind using sulfur. This version is different. They start using sunlight, carbon dioxide, and water. And in the process, they release something totally unexpected: oxygen. That's right, actual, breathable oxygen. Well, not breathable, just yet. Because Earth isn't ready. The Great Oxygenation Event, Earth's first mass extinction. You might think oxygen is a good thing. After all, we need it to live, right? But back then? It was toxic. The planet's early life was anaerobic, meaning it couldn't survive in oxygen. So when cyanobacteria started pumping it into the atmosphere like it was doing everyone a favor, it was actually creating the first major extinction event. Billions of microbes, gone. Choked out by the very thing that would one day let humans breathe. It's like someone turning on the air conditioning in an ice cream shop. Nice for some, disaster for the rest. The air turns blue, but let's talk visuals for a second. Before oxygen, Earth's skies weren't blue. They were likely orange or pink, filled with haze and volcanic gases. But as oxygen began building up, the atmosphere started to clear. Blue light scattered through the air. Clouds began forming in patterns we'd recognize today. And just like that, Earth started to look familiar. Still no trees. Still no birds. But finally, the first taste of a breathable sky. Oxygen in the water, rusting the planet. Here's another twist. Before oxygen could fill the air, it first had to deal with Earth's oceans. Why? Because they were full of iron. Dissolved iron, just floating around like a mineral soup. And when oxygen meets iron, they combine and form rust. So for millions of years, oxygen got trapped, making rust in the oceans. That's right, the planet literally rusted itself from the inside out. The evidence? We can still see it today in ancient rocks called banded iron formations, red and gray stripes in stone that are over 2 billion years old. They're basically Earth's version of blood stains. Building the ozone layer. But oxygen didn't just change the oceans or the atmosphere. It did something else, something huge. High up in the sky, some of that oxygen turned into ozone, a special form of oxygen with 3 atoms instead of 2. And ozone? It acts like Earth's sunscreen. It started blocking out deadly ultraviolet radiation from the sun, the same kind of radiation that would fry anything trying to survive on land. No ozone equals no land life. But thanks to those early oxygen producers, Earth was slowly becoming habitable. The first ecosystem engineers, so let's talk respect. Cyanobacteria weren't just floating blobs. They were engineers. Planet-shaping pioneers. They didn't build cities. They didn't talk. But they remodeled the entire planet just by existing. They laid the groundwork for everything that would follow, plants, animals, us. Without them, we're not here. And what did they want in return? Absolutely nothing. They just kept floating in the sun, multiplying quietly, like the overachievers they were. Stromatolites, the monuments of microbes. Now if you wanted to go back and see these cyanobacteria in action, there's a weird kind of monument they left behind. They're called stromatolites. They look like squishy rocks or weird coral, but they're actually layered structures built by microbial mats. Think of them as bacterial skyscrapers, built slowly, layer by layer, over thousands of years. You can still find them today in places like Shark Bay, Australia. And they're not fossils, they're alive. Still bubbling. Still working. Still making oxygen, billions of years later. Talk about long-term projects. Not everyone survived the revolution. While oxygen was great news for the future, it was bad news for most existing life at the time. Anaerobic life couldn't handle this new atmosphere. For them, oxygen was like poison. So as the air changed, a lot of early microbes died out. Gone. Erased. Only the ones that could adapt or hide survived. Some retreated into deep mud or ocean vents where oxygen couldn't reach. Others mutated and learned to work with the new rules. And a few figured out how to use oxygen to burn energy even better. That was the beginning of something big. Because oxygen isn't just breathable, it's powerful. It lets cells make way more energy than before. And more energy means more complex life, soon. But not just yet. The long, quiet wait after this massive shift, Earth went quiet again. Oxygen levels rose. Then dropped. Then rose again. The world was adjusting. Settling. Getting ready for its next leap. It would take hundreds of millions of years. But when it finally happened, oh boy. Life would go from invisible microbes, to things with heads, legs, and attitudes. But here, in this quiet chapter, the stage was set. Take a breath, you've earned it. So now, as you lay back and close your eyes, just think. The air in your lungs, the blue sky you see during the day, the clouds, the breeze, the very life you live. All of it began with tiny, invisible cells floating in ancient oceans, quietly making oxygen. Not for you. Not for anyone. Just because that's what they did. And in doing so, they gave us the world. Last time, tiny microbes turned Earth into an oxygen-making machine. They didn't mean to start trouble. But they kind of did. Because now that oxygen is rising, the atmosphere is changing. And that change? It's about to tip the entire planet into a deep freeze. Not a winter. Not an ice age, we're talking about Earth turning into a giant frozen snowball. Let's go. What even is a snowball Earth? It sounds like a joke, right? Like some scientist had a little too much coffee and went, hey, what if Earth just froze completely? But no, it's real. At least twice in Earth's history, the planet got so cold that ice covered almost the entire surface. From pole to pole. Even the oceans. It wasn't just cold. It was extreme. Lethal. A full-body planetary deep freeze. And the craziest part? It might have been caused by those helpful little cyanobacteria from the last chapter. Oops. How Earth accidentally froze itself. So here's what happened. As cyanobacteria kept releasing oxygen, that oxygen reacted with methane in the atmosphere. Now, methane is a powerful greenhouse gas. It traps heat really well, like a thermal blanket for Earth. But oxygen broke it down. Methane levels dropped. And with less methane, Earth lost its blanket. Temperatures started to drop. Then something else kicked in, ice. Ice reflects sunlight. So as glaciers formed near the poles, they reflected more sunlight back into space. Less sunlight equals colder Earth. Colder Earth equals more ice. More ice equals even more reflection. And just like that, we had a runaway freeze. Imagine the scene. Picture Earth around 700 million years ago. From space, it looks like a glowing white marble. No blue oceans. No green continents. Just ice and snow, wrapping around the globe. Even near the equator, the oceans are frozen. And it's not just the surface. Some scientists believe the ice may have been kilometers thick in places. Volcanoes still erupt. But everything else? Frozen. Still. Silent. Like the planet hit the pause button. Life under the ice. Now here's the question: if Earth was frozen, did life just die? Surprisingly, no. Life hung on. Barely. Remember those deep-sea hydrothermal vents? They were still pumping out heat and minerals beneath the ocean. And some microbes, tough little survivors, lived near those vents. Others may have hidden in small pockets of liquid water, where the ice was thin. Or in brine channels, cracks in sea ice filled with salty slush. They weren't thriving. But they weren't giving up either. In the coldest moment in Earth's history, life held on. The frozen planet sleeps. The snowball Earth period didn't last forever. But it wasn't short either. Some of these frozen episodes may have lasted for tens of millions of years. Imagine that. Generation after generation of microbes, living in the shadows. Waiting. And above them, Earth just frozen. No weather. No rain. No thunder. Just the silent crunch of ice stretching across oceans. How did Earth escape the deep freeze? Eventually, something had to give. And that something was volcanoes. Even while Earth was frozen, volcanoes never stopped erupting. They kept releasing carbon dioxide into the atmosphere. But here's the twist: that carbon dioxide had nowhere to go. Normally, it would get absorbed by oceans or weathered rocks. But those were covered in ice. So over millions of years, carbon dioxide just built up. Until finally, there was enough to trigger the greenhouse effect again. Temperatures slowly rose. Ice began to melt. Sunlight started getting absorbed. And after millions of years in the freezer, Earth thawed. The great melt, and oh, what a meltdown it was. As the glaciers retreated, they unleashed mega floods. Rivers of icy water carved through the land. Oceans rose. Chemical reactions in the water went wild, especially with all that trapped carbon dioxide. The oceans became acidic. Storms rolled across the world. It was dramatic. Violent. Messy. But also, it was the beginning of a new world. The aftermath: Earth reborn. Once the planet stabilized, Earth didn't go back to what it was. The post-snowball Earth had a new atmosphere, a new climate, a new ocean chemistry, and most importantly, it had new possibilities. That harsh freeze may have acted like a filter, wiping out the weak and pushing life to evolve. Some scientists even believe this is what set the stage for complex life to finally emerge. Like a long, dark winter, followed by spring. Evidence in the rocks. Now you might be wondering, how do we know any of this happened? Well, the clues are locked in rocks. In places like Namibia, Canada, and Australia, geologists have found glacial deposits in tropical zones. Layers of rock called cap carbonates, formed from rapid warming after a freeze. Isotopic signatures that scream, something big happened. It's like piecing together a frozen crime scene, layer by layer. The Earth left behind the receipts. Snowball Earth, not just once. Here's the wild part. This didn't happen just one time. There were multiple snowball Earth events, possibly 2 or 3 major ones, one around 2.4 billion years ago, another around 700 million years ago, and maybe a few smaller ones in between. Each one pushed life to its limits. Each one rewired the planet. And each one brought us one step closer to animals, plants, and eventually, us. Sometimes, you have to freeze to grow. It sounds strange. But maybe Earth needed to freeze. To pause. To purge. To prepare. Because after this, life doesn't just return. It explodes. Whole new branches of evolution start growing. But for now, as you lie there listening, let yourself imagine Earth, asleep beneath a blanket of ice. Cold. Still. Silent. But underneath that silence, the heartbeat of life never stopped. The planet has just thawed from one of its most brutal deep freezes. The snowball Earth era is finally over. Skies are clearing. Oceans are warming. And after billions of years of floating as solo cells, life decides. You know what? Teamwork might not be so bad. This chapter is the story of life's biggest glow-up yet. From single-celled microbes, to multicellular organisms. From lonely blobs, to communities of specialized cells. It took a while. But when it happened? Oh, it changed everything. Why stay single when you can merge? For over 3 billion years, life was single-celled. That's not a phase, that's most of Earth's entire history. These tiny cells ruled the oceans alone. No organs. No eyes. Just microscopic hustle. But eventually, some of them started sticking together. At first, just simple clumps. Hanging out. Sharing resources. No big deal. But over time, these clumps got smarter. Cells started to specialize, one handled movement, another digestion, another defense. And just like that, life went from solo acts to full-blown symphonies. Multicellularity was born. Why it took so long, you might wonder. Why didn't cells team up sooner? Well, going multicellular is risky. You have to give up some independence. You rely on others. And if one cell messes up, the whole group can suffer. Plus, early Earth just wasn't stable enough. Too hot. Too cold. Too toxic. But after the snowball events, conditions were just right. More oxygen, more nutrients, a calmer environment. It was finally safe enough to evolve. The Ediacaran mystery around 600 million years ago, the fossil record starts getting interesting. We begin to find weird, soft-bodied creatures. Not plants. Not animals. Not quite anything we have today. These odd lifeforms are called the Ediacaran biota, named after Australia's Ediacara Hills, where their fossils were first discovered. Some looked like leaves. Some looked like pancakes. Others resembled giant frilly worms or floating carpets. And all of them? Gone. Extinct. No modern descendants. It's like evolution took a wild experimental art phase, then threw the whole sketchbook away. What did these creatures even do? That's the thing, we're not entirely sure. They didn't leave behind bones. Or teeth, or even obvious body parts. But we think they absorbed nutrients from water, anchored themselves to seafloors, maybe moved, very slowly. Some may have formed colonies. Others lived solo. But one thing's clear, they weren't microbes anymore. They were multicellular, and they were the first visible life on Earth. If you stood on an ancient Ediacaran beach, you might have seen them, swaying like jelly pillows beneath shallow waters. Weird. Quiet. Ancient. Oxygen was the secret ingredient. None of this would have happened without oxygen. Seriously, it's the unsung hero of this whole chapter. You see, multicellular life needs a lot of energy. And oxygen helps cells create more energy than they ever could before. Without it, cells are stuck on basic mode. With it, they can build bodies, grow muscles, fire neurons, create brains. Oxygen equals upgrade fuel. Thanks again, cyanobacteria. A slow, gentle boom. The Ediacaran period wasn't a fireworks show. It was more like a soft hum rising in the background. No predators yet. No claws. No chasing. Just creatures living in peaceful, slow-motion weirdness. But something was building, and when it finally exploded, well, that's the next chapter. For now, this era was all about experimentation. Life tried new shapes, new textures, new ways of being alive. And while many of those experiments didn't last, they paved the way for what came next. Fossils, Earth's memory cards. The thing about soft-bodied creatures is, they're terrible at fossilizing. No bones equals no guarantees. But in just the right conditions, quiet seas, fine sediments, low oxygen, some of them left behind impressions in rock. Like ancient shadows. Still, we don't have much. It's like trying to reconstruct a movie from 3 blurry screenshots. But what little we do have, it's enough to prove life was changing fast. What it means to be complex. So what's the big deal about being multicellular? It's not just about size. It's about organization. Multicellular creatures can heal when damaged, grow into specialized shapes, reproduce in more efficient ways, develop systems like nerves, muscles, and circulatory networks. Basically, complexity unlocks new strategies for survival. The leap from one lonely cell to trillions working in sync isn't just a biological upgrade. It's the reason we can walk, talk, laugh, and dream. Where were all the animals? Funny enough, no animals yet. At least, not the kind we recognize. No fish. No bugs. No tentacles, even. But the clock is ticking. Within the next few chapters, animals are going to show up, and they're going to party hard. For now, the world belongs to these slow, silent pioneers. Their time on stage is brief, but essential. The calm before the explosion. As this chapter closes, Earth is standing on the edge of something big. The oceans are rich with nutrients. The air has more oxygen than ever. And life? It's finally learned to build bodies. Everything is about to change. But here, in this quiet chapter, we can still pause. Breathe. Look around. Picture shallow seas, warm and calm. Sea floors covered with soft, strange creatures, their movements slow, their lives silent. No predators. No panic. Just the hum of something new, beginning to form. Even the weirdos matter. The Ediacaran biota may be extinct, but they matter. They represent life's first brave steps into complexity. They show that evolution doesn't move in straight lines, it zigzags. Experiments. Tries weird stuff. Some creatures win. Others vanish. But all of them push the story forward. And that story? It's about to get wild. Last time, Earth was experimenting. Soft creatures floated through shallow seas. No eyes. No teeth. No rules. It was quiet. Peaceful. Almost. Too peaceful. But now? Boom. Life is about to hit the gas pedal. No more slow evolution. No more gentle changes. Welcome to the Cambrian explosion, when life said, "Alright, let's get weird." What even is the Cambrian explosion? So here's the deal. Around 541 million years ago, life went from simple to insane, and it happened in a blink of geological time. In just 10 to 20 million years, which sounds long, but it's nothing on Earth's clock, organisms evolved eyes, legs, shells, spikes, brains, and teeth. Before? Squishy blobs. After? Creatures that could hunt. Run. Hide. Fight. Basically, nature invented drama. The world gets its first ecosystem. Up until now, life was like a sleepy art gallery. No action. Just vibes. But during the Cambrian explosion, it turned into an arena. Predators and prey, burrowers and swimmers, herbivores, carnivores, filter feeders. For the first time, life didn't just exist, it interacted. There was strategy. There was fear. There was competition. The food chain was born. And once that started, evolution kicked into overdrive. So, what caused it? To this day, scientists don't fully agree on why the Cambrian explosion happened. But here are some ideas. 1. More oxygen. Earth's oxygen levels had finally reached a point where larger, more active animals could survive. 2. New predators. when creatures began eating each other, natural selection went turbo mode. Get better, or get eaten. 3. Genetic innovation. Genes like Hox genes may have evolved, allowing creatures to build more complex body structures. 4. Better skeletons. Shells and hard parts made animals tougher, and easier to fossilize. Whatever the reason, the result was chaos, beautiful, creative, life-changing chaos. Meet the weirdos of the Cambrian. So who exactly showed up to this ancient party? Let's meet a few of the Cambrian celebrities. Trilobites, like armored bugs with built-in sunglasses, crawled across seafloors in huge herds. One of the most successful creatures of all time, lasted 270 million years. Soap-Opabinia 5 eyes. A long tube-like body. And a claw-faced hose sticking out of its head. Basically nature's first fever dream. Bug Hallucigenia, a tiny worm with spikes on its back and tentacles on its belly. Scientists weren't even sure which way was up for decades. It looked confused and a little cursed. Octopus Anomalocaris, the first real predator. Giant eyes. Sharp feeding arms. A circular jaw that spun like a blender. Top of the food chain, a true nightmare with fins. These creatures were bizarre, beautiful, and nothing like what came before. It was evolution on experimental mode. Life starts making plans for the first time. Creatures built shells to protect themselves, dug burrows to hide, formed eyes to see, grew limbs to move. They even started communicating, in simple ways. Maybe through chemicals, maybe through movement. Whatever worked. The Cambrian wasn't just a show-off moment, it was the moment when life learned how to build tools to survive. And once that happened, nature never looked back. Fossils, Earth's first photo album. Before this, the fossil record was sparse. Soft creatures don't fossilize easily. They vanish without a trace. But now, with all these shells, plates, claws, and bones, the rocks are suddenly full of fossils. That's why we know so much about the Cambrian explosion. It gave us evidence. And the best evidence of all? A magical place called the Burgess Shale in Canada. Here, scientists found some of the best preserved Cambrian fossils in the world, like snapshots frozen in stone. The detail is so good, you can sometimes see their guts. Literally. A whole new world. The Cambrian seas were wild. Imagine swimming through shallow blue waters, herds of trilobites crawling beneath you, spiky worms bobbing like balloons, jelly-like creatures drifting silently, predators with saw-blade mouths lurking in the shadows. It was alien. It was crowded. It was alive. Earth had gone from a quiet microbial planet to a fully chaotic, fully living world. And then it slowed down after the Cambrian explosion. Life didn't stop evolving. But the pace changed. The Big Bang of creativity calmed a bit. Creatures got better at surviving. Predators got smarter. Defenses got tougher. And for the next tens of millions of years, life just built on what it had. The Big Bang had laid the groundwork. Now it was time to fill in the details. Why it matters. The Cambrian explosion wasn't just a bunch of new creatures. It was the origin of almost every major animal group we have today. Mammals? Traced back to Cambrian ancestors. Fish? Same. Even insects, reptiles, and birds, their blueprints started here. It was like nature unlocked the full version of evolution, and went nuts with it. And without this explosion, there's no us. No dogs. No whales. No bedtime stories. So now, rest easy as you lie back and close your eyes. Imagine it. A sea, 500 million years ago. Crystal clear. Shallow. Warm. And beneath the surface? A riot of life. Eyes blinking. Fins flapping. Spikes glittering. Mouths chomping. It's noisy. Busy. Alive. The Cambrian was nature's first real masterpiece. A strange, electric moment where life realized, I can be anything. And it was. We just witnessed the Cambrian explosion, a burst of wild creativity where life showed off its wildest looks, spikiest armor, and weirdest eyes. But now? Now we enter a darker chapter. Because where there's life, eventually, there's death. And not just regular death. We're talking about the first mass extinction in Earth's history. The first time the planet said, too much. Time to reset. Let's dive in. Earth's new normal by now, around 485 million years ago, Earth had settled into a rhythm. The oceans were alive with trilobites, sponges, early snails, and floating plankton. Soft creatures dug into mud. Jellyfish bounced around like watery ghosts. It wasn't a peaceful world, but it was working. Then came the Ordovician period. And for a while, it was beautiful. Coral reefs grew. Fish started to show up, jawless, but still fish. Plants made their first bold steps onto land. It was a blooming, evolving, colorful time. Until, it wasn't. So, what happened? The first mass extinction wasn't triggered by a meteor. Or volcanoes. Or some alien experiment gone wrong. It was something way more subtle, and colder. Around 443 million years ago, Earth entered a massive ice age. But this wasn't your average winter. This was planetary-scale freezing. Glaciers expanded. Sea levels dropped. The oceans, which were the center of all life, got colder, shallower, and less stable. Many marine species couldn't adapt. They froze. They starved. They vanished. The drop that drowned a world. The key killer wasn't just the cold, it was the sea level drop. Most life back then lived in shallow oceans, especially along coastlines. But as glaciers formed, they sucked up massive amounts of water. The sea pulled back like a receding wave, and took entire ecosystems with it. Coral reefs dried out. Shoreline habitats disappeared. Species that had thrived for millions of years were suddenly homeless. It was like unplugging the aquarium, with everyone still inside. The stats, a brutal toll. Scientists estimate that this extinction event wiped out around 85% of all marine species. That's almost everything. Gone. Entire families of trilobites disappeared. Ancient sponges, gone. Brachiopods and graptolites, extinct by the thousands. It was Earth's first real taste of mass death. And it would not be the last. Wait, there were two waves. Here's the twist. The extinction didn't happen all at once. There were two pulses. One, the first came with the Ice Age, the freeze, the sea level drop, the collapse of warm habitats. Two, the second hit when things warmed up again, fast. That sudden warming threw the oceans into chaos. Water temperatures spiked. Ocean currents shifted. Oxygen levels dropped. Creatures that barely survived the first hit couldn't handle the second. It was like getting knocked down, and then getting stepped on as you tried to stand. Life hits reset. After the extinction, the oceans were quieter. The once crowded ecosystems? Empty. But Earth wasn't done. Because here's the strange thing about mass extinctions, they're brutal. But they clear the board. Make room. Life doesn't give up. It reshuffles, adapts, and tries again. After this extinction, new creatures rose to take the place of the old. And some of them? They had jaws. The rise of the vertebrates among the survivors were early fish, small, armor-plated, jawless swimmers. They didn't dominate right away. But in the new, post-extinction world, they got a chance to grow. They started evolving better fins. Stronger skeletons. More efficient gills. Eventually, jaws. Yes, actual mouths that could bite. For the first time, predators could chew instead of just suck or scrape. And that? That changed the game forever. Why the first extinction matters. This was more than just a sad chapter in life's story. It showed us that Earth can change fast. Life is fragile. And survival depends on adaptability. It also revealed something important about evolution. Sometimes, big leaps need a little destruction to happen. When the dominant species disappear, new ones step up. Extinction clears the path for innovation. Painful. But powerful. Nature's harsh lesson: mass extinctions aren't personal. They're not a punishment. They're part of how Earth works. Climate shifts. Continents drift. Seas rise and fall. And life either keeps up, or gets left behind. It's cold. But that's the rulebook. Earth doesn't negotiate. It transforms. The world that remained: imagine the oceans after this extinction. Quieter. Colder. Fewer colors. Fewer creatures. But among the survivors, were the seeds of the future. Tiny fish with primitive backbones. Early plankton. Simple plants stretching onto muddy shores. The world wasn't finished. It was just paused. Waiting for the next act. Close your eyes, and listen as you lie there now. Picture it. Not an explosion. But a silence. Not a bang, but a slow fade. Millions of creatures disappearing into history. Not with screams, but with stillness. And yet, beneath that silence, somewhere in the cold, life is holding on. Tiny. Tough. Quiet. Just enough to start again. Earth has just gone through its first major extinction. The oceans are quiet. The shorelines are bare. And life is starting over. But don't get too comfortable. Because from this stillness comes a wave of monsters, big ones. With teeth. And armor. And attitude. Welcome to the Silurian and Devonian periods, the time when Earth said, let's build some beasts. The Silurian, Earth gets its balance back. Let's start with the Silurian period, about 443 to 419 million years ago. After the icy extinction in the last chapter, Earth started warming up again. Glaciers melted. Sea levels rose. And ecosystems began to recover. This time, nature wasn't just rebuilding. It was upgrading. Coral reefs came back, bigger and better. Tiny jawless fish began swimming with style. And for the first time, plants started creeping onto land. Nothing leafy or tall yet. Just small, mossy things near the water's edge. But still, that's huge. Land wasn't just for rocks anymore. It was waking up. Underwater arms race, fish start evolving. Now let's go underwater. This is where things get interesting, and scary. Fish were no longer soft and shy. They were arming up. Meet the ostracoderms, jawless, armored fish with bony plates like nature's first helmets. They weren't fast, but they were protected. Then came the game changer, jaws. Yes. Actual biting mouths. This gave some fish a huge advantage. They could catch prey. Tear it up. Eat it faster. Suddenly, being cute and toothless just wasn't enough. Welcome to the Devonian period, also known as the Age of Fishes. The Devonian explosion, fish everywhere. It's now about 419 to 359 million years ago. The Devonian oceans are absolutely packed. Armored fish. Cartilaginous fish. Lobe-finned fish. Ray-finned fish. Spiny sharks. Big ones. Fast ones. Sharp ones. It's like the Cambrian explosion got a sequel, but this time, the predators were leading the show. And then, there was Dunkleosteus. Dunkleosteus, king of the Devonian. This guy deserves his own spotlight. Nearly 30 feet long, covered in armor like a medieval tank, had a jaw that could snap with the force of a modern crocodile. Dunkleosteus didn't have teeth, it had bone blades in its jaw. Bone. Blades. It didn't chew. It crushed. This was the top predator of its time. If you were swimming in the Devonian and you saw a shadow, you better hope it wasn't Dunk. Meanwhile, on land, while all the ocean chaos was happening, land was quietly evolving. Plants were getting bolder. No longer just hugging the shoreline, they were starting to grow taller, develop roots, and form the first forests. Tiny creatures like millipedes, spiders, and scorpions followed. Insects showed up too, weird, wingless ones at first. But still, life had officially invaded land. Earth was becoming a true two-zone planet, wet and wild below, green and crawling above. One brave fish steps out. Now here comes one of the most important plot twists in all of history. Some lobe-finned fish, the ones with fleshy, muscular fins, began venturing into shallow, swampy waters. Some used their fins to push through mud. Some may have gulped air. Over time, those fins started to look a bit like legs. Meet Tiktaalik, the fish that almost wasn't a fish. It had gills and lung scales and a neck, fins with bones like wrists. Tiktaalik didn't walk on land yet. But it peeked at it. It was the test run for something big. The first amphibians appear eventually. Some of Tiktaalik's descendants made the jump. They crawled out of the water, and stayed. These early amphibians still needed water to lay eggs, but they could breathe air and walk. For the first time, a backbone wiggled across land. That sound? That's evolution cheering. Because these were the ancestors of frogs, salamanders, reptiles, birds, and even us. All from one brave fish that got tired of swimming. The Devonian ends in darkness, but just as things were getting exciting, Earth hit another wall. Near the end of the Devonian, something went wrong. Multiple extinction events, small ones, close together, wiped out about 75% of all species. Coral reefs collapsed. Armored fish vanished. Entire lineages disappeared. Why? We're still not sure. Maybe it was a drop in oxygen, cooling climates, asteroid impacts, giant volcanic eruptions. Whatever it was, the age of fishes was over. What survived? The creatures that made it through the Devonian extinction were smaller, tougher, and more adaptable. Sharks survived. So did some bony fish. And those first amphibians? They held on, barely. The path forward wouldn't be easy. But it was open. Why this chapter matters? This chapter was about expansion. Life filled the oceans like never before. Fish ruled with teeth and armor. Plants transformed the land, and vertebrates made their first steps onto dry ground. It was explosive, chaotic, and strangely elegant. Because every scale, every fin, every leap onto land, led us one step closer to the world we know today. Close your eyes, and picture its shallow seas shimmer in the sunlight. Coral reefs bloom beneath the waves. Forests stretch along the shores. Insects crawl among mossy trunks. And in the water, a giant shadow moves, silent, armored, unstoppable. The Devonian wasn't just wild. It was evolution on full volume. And though it ended in silence, the echoes still shape us. The oceans have just calmed down from the Devonian madness. Giant armored fish have vanished. Forests have taken root. And on land, a new kind of life is stretching its legs, literally. Welcome to the Carboniferous and Permian periods, a time when bugs ruled the skies, amphibians squelched through swamps, and Earth prepared for its biggest extinction ever. Let's begin. The Carboniferous period, a jungle planet. It's around 359 to 299 million years ago. The Carboniferous Earth feels cozy. The climate is warm, humid, tropical. Rain falls often, and nearly everything is covered in dense, green jungle. Think giant ferns, mosses, and towering club moss trees as tall as buildings. There are no flowers yet. No fruits. Just green. Everywhere. And buried under those forests? Swamps. Big ones. Filled with decaying plants. All that plant matter? It's going to become something important: coal. That's why it's called the Carboniferous. Coal formed here, and millions of years later, humans would dig it up and burn it. But let's not get ahead of ourselves. Right now, Earth is just breathing in oxygen. Oxygen goes crazy. The Carboniferous atmosphere had more oxygen than today, maybe up to 35%. That's a lot. And it had a side effect: bugs got huge. Seriously. Meet Meganeura, a dragonfly the size of a seagull. Arthroplura, a millipede the length of a car, giant scorpions and flying insects with wingspans longer than dinner plates. Why so big? Because insects breathe through holes in their bodies, and more oxygen equals bigger bugs. It was like a creepy crawly version of Jurassic Park. Amphibians take over the land while the insects were dominating the skies and swamps. Early amphibians were having their moment too. They looked like a mix between giant salamanders and chunky lizards. Some had legs like paddles. Others waddled through muddy jungle floors. They laid eggs in water, just like frogs today, so they still needed ponds, lakes, or damp environments to survive. But they were the first real vertebrates to live on land. Spines. Limbs. Lungs. A big step forward. The first trees and forest ecosystems. Here's something wild. Carboniferous forests had no flowers, no fruit, no birds, no mammals. Just ferns, horsetail seed ferns, lycopods. Trees dropped spores instead of seeds. And the forest floor? Covered in thick, spongy roots and rotting plants. No worms to break them down. Just fungus, and time. These forests were quiet, but they were powerful. They shaped the atmosphere, the soil, and the future of life itself. The rise of reptiles. Eventually, evolution handed out a new upgrade, the amniotic egg. This egg had a protective shell and its own water supply. Which meant, no more laying eggs in ponds. Life could finally break free from water. This gave rise to the first reptiles, small, scaly pioneers who could lay eggs on dry land. They were the ancestors of lizards, snakes, turtles, dinosaurs, and us. And they had one huge advantage: freedom. They didn't have to stay near the swamp. They could explore. Roam. Expand. The amphibians? They were stuck. Enter the Permian period. Around 299 to 252 million years ago, the Carboniferous ended and the Permian began. Earth was changing, big time. The continents merged into one giant landmass called Pangaea. It looked like a broken pancake, surrounded by one massive ocean called Panthalassa. With so much land together, Earth's weather got weird. Hot summers, cold winters, massive deserts, intense seasons. Rainforests started to die out. Swamps shrank. Many amphibians couldn't adapt. But reptiles? Oh, they were thriving. Synapsids, the almost mammals during the Permian, one group of reptiles started to stand out. They weren't quite mammals yet. But they were on the way. Meet the synapsids. Some looked like lizards. Some like furry crocodiles. And one of the most famous? Dimetrodon, a four-legged beast with a huge sail on its back. People often confuse it with a dinosaur. But nope, it came way earlier. Dimetrodon and its relatives were the dominant predators of the Permian. And their descendants? They'd eventually become mammals. Yeah, us. The Permian, innovation meets trouble. During the Permian, life was inventing fast. Better jaws, stronger limbs, tougher skin, bigger brains. Reptiles were spreading across the land. Some became herbivores. Some became predators. Some even started standing upright. It looked like evolution was preparing for a bright future. But the clock was ticking. Because the Permian didn't just end. It exploded. The Great Dying. At the very end of the Permian, around 252 million years ago, Earth went through the worst extinction event in its entire history. Worse than the dinosaurs. Worse than anything before or after. We call it the Permian-Triassic extinction. Or just, the Great Dying. Up to 96% of all marine life and 70% of land species disappeared. Gone. Coral reefs collapsed. Forests turned to deserts. Whole families of creatures were erased. What caused it? Scientists think massive volcanic eruptions in Siberia released tons of CO2, tons of methane, acid rain, global warming, ocean acidification. Basically, everything went wrong at once. The skies darkened. The air thickened. The oceans turned toxic. Earth became unlivable for millions of years. What survived? Not much. But a few tough reptiles and tiny creatures made it through. among them? Some small therapsids, the ancestors of mammals. And early archosaurs, the ancestors of dinosaurs. The next chapter would belong to them, but for now? The world was quiet. Broken. Burned. Why this chapter matters: this era taught Earth a harsh lesson. Innovation can't stop disaster. Size doesn't guarantee survival. Life must always adapt, or vanish. And yet, out of the ashes of the Permian, came the beginnings of something new. Dinosaurs. Birds. Mammals. And someday, humans. Close your eyes, and feel the shift. Picture a dense swamp, buzzing with giant insects. Amphibians croak in the shadows. Reptiles creep along the trees. Oxygen is thick. Life is loud. Then slowly, it fades. Forests die. Ash falls from the sky. And silence takes over. But even in the silence, something is still breathing. Waiting. The next age is coming. But first, the world must heal. Earth has just survived the Great Dying, the worst extinction event in history. Almost everything is gone. Oceans are empty. Land is quiet. Forests burned. But if Earth has taught us one thing, it never stays down for long. This chapter? It's the comeback story. Welcome to the Triassic period, the first part of the Mesozoic era, aka the Age of Reptiles. The survivors are ready. And the world? It's about to get reptilian. Picking up the pieces, the year is around 252 million years ago. The Permian extinction has wiped out nearly all life. Only the toughest creatures are left. And the Earth itself? Still recovering. Volcanic skies, unstable climate, oxygen levels are low, heat is intense, the land is mostly dry. The seas are quiet, but beneath the surface, in burrows, shadows, and swamps, life is starting to stir. Who survived the apocalypse? Let's check the roll call. Some amphibians survived, smaller, tougher versions. A few therapsids, mammal-like reptiles, held on. Some early archosaurs, the ancestors of crocodiles, pterosaurs, and dinosaurs, made it too. These survivors were like the underdogs of evolution. And now? It was their time to shine. The rise of the reptiles. Reptiles had a secret weapon, the amniotic egg. Unlike amphibians, they didn't need to lay eggs in water. They could lay them on land, in drier places, far from danger. They also had scaly skin to prevent water loss, stronger legs to lift their bodies, better lungs for breathing dry air, sharp teeth and claws. They were fast, efficient, and adaptable. So while the world was still struggling, reptiles started moving in. Enter the archosaurs. Archosaurs were a special group of reptiles. The name means ruling lizards. And they earned it. This group included early crocodile-like creatures, flying pterosaurs, and yes, the very first dinosaurs in the Triassic. Dinosaurs weren't huge yet. They were small, bipedal, and fast. Think dog-sized predators, not towering beasts. But they had something special: hollow bones, upright legs for better running, keen senses, and most importantly, they were built to last. Therapsids, the other contenders. While dinosaurs were rising, the therapsids, those mammal-like reptiles, were still around. Some were herbivores. Some were predators. Some even had whiskers, possibly fur, and warm-blooded metabolism. They were smart, active, and efficient. It looked like they might take over the world. But nature had other plans. The first flying reptiles, meanwhile, another archosaur group, was taking to the skies. Pterosaurs, the first true flying vertebrates. They weren't birds. They weren't bats. They were something else entirely. Long fingers stretched into wings. Hollow bones for lightness. Membranes of skin, perfect for gliding. From tiny sparrow-sized species to giants with 30-foot wingspans, pterosaurs owned the skies before birds were even a thing. It was an aerial revolution. Back in the oceans, let's not forget the sea. After the Permian extinction, marine reptiles began showing up. Meet nothosaurs, long-necked, flippered hunters; ichthyosaurs, dolphin-shaped reptiles with huge eyes and fast tails, plesiosaurs, with short bodies and long necks. Yes, like Nessie, these weren't fish. They weren't dinosaurs either. But they ruled the oceans just the same. Earth was rebuilding its food chains. And reptiles were leading the charge on every front. Dinosaurs take the lead. By the late Triassic, around 230 million years ago, dinosaurs had started pulling ahead. They split into two main groups. 1. Saurischians, lizard-hipped, including future meat-eaters like T-Rex and longnecks like Brachiosaurus. 2. Ornithischians, bird-hipped, including armored dinos, duckbills, and horned ones. At this point, most dinosaurs were still small. But they were fast, smart, and adaptive. As ecosystems changed, dinosaurs filled more and more roles: predators, herbivores, scavengers, runners, stalkers. They weren't kings yet. But they were rising fast. One more mass extinction, because why not? Just as dinosaurs were getting comfy, Earth pulled another plot twist. At the end of the Triassic, around 201 million years ago, there was another mass extinction. Likely caused by massive volcanic activity, climate change, rising CO2, ocean acidification. It wasn't as bad as the Permian disaster, but it still wiped out many amphibians, lots of marine life, almost all therapsids, and a bunch of rival reptiles. Guess who survived? Dinosaurs. With their competition gone, they finally had the world to themselves. Why the Triassic was so important? This chapter isn't about giant beasts or famous names. It's about resilience. Earth got knocked down, hard, but life came back stronger. The Triassic was a transition, from scattered survivors to global empires, from small reptiles to ruling dinosaurs, from empty oceans to predator-packed seas. Everything we think of as prehistoric, it started here. The spark becomes a flame. When the Triassic began, Earth was a broken wasteland. By the end, the skies had wings. The oceans had hunters. And the land belonged to dinosaurs. The flame was lit. And the next chapter? It's going to roar. Close your eyes, and feel it begin. Picture a dry, cracked world. The sun burns above, dust swirls across empty plains. Then, in the distance, footsteps. A small bipedal dinosaur darts between trees. A pterosaur glides overhead. And deep in a burrow, a tiny therapsid twitches its ears, hiding. The stage is set. The age of reptiles has officially begun. And the giants are coming. Last chapter, we watched reptiles rise from the ashes of mass extinction. Dinosaurs appeared. Pterosaurs took flight. Oceans filled with marine hunters. But now? It's time for the main event. The Triassic was the spark. But the Jurassic and Cretaceous periods? That's the wildfire. The age of true dinosaur domination has begun. A quick timeline check. Let's get our bearings. Triassic period, 252 to 201 million years ago, dinosaurs begin. Jurassic period, 201 to 145 million years ago, dinosaurs take over. Cretaceous period, 145 to 66 million years ago, dinosaurs peak and fall. Altogether, dinosaurs ruled Earth for around 180 million years. That's so long. If dinosaurs had invented Wi-Fi, we'd still be using it today. Jurassic, Earth turns into a dinosaur paradise. As the Triassic ends, the Earth goes through massive changes. Pangaea, the supercontinent, starts breaking apart. This creates new oceans, long coastlines, more rainfall, warm, humid climates. In short, perfect conditions for life to explode. Forests grow. Ferns and conifers cover the land. And dinosaurs? They start getting bigger. Faster. Weirder. The long-necked giants. Let's talk sauropods. These were the long-necked, long-tailed plant eaters, some of the largest animals to ever walk the earth. Jurassic superstars include Brachiosaurus, as tall as a 4-story building; Diplodocus, longer than a bus; then another bus; Apatosaurus, formerly known as Brontosaurus. Don't worry, he's back now. They weren't fast. They weren't clever. But their size alone kept most predators at bay. Eat leaves. Walk slowly. Repeat for 100 years. Honestly, a peaceful lifestyle. And then came the hunters, but where there are herbivores, there are predators. Meet the theropods, two-legged meat-eaters who were fast, fierce, and clever. Jurassic icons include Allosaurus, big jaws, sharp claws, Jurassic Park attitude Ceratosaurus, short snout, horn on its nose Megalosaurus, the first dinosaur ever named. These were the ancestors of what would later become T-Rex. But don't worry, he's not here yet. Still, they were terrifying in their own right. They hunted in packs. They scavenged when needed. They ruled the food chain. Pterosaurs, sky kings up above, pterosaurs still soared. Some had fur-like fuzz. Some had wingspans over 30 feet. Some glided over oceans, snatching fish with long beaks. They weren't dinosaurs, they were their own thing. But they shared the sky with their land-dwelling cousins. And in a world without birds, yet, pterosaurs were the original pilots. Oceans of terror underwater. Chaos continued. The seas were full of pliosaurs, giant, short-necked marine reptiles with powerful jaws ichthyosaurs, sleek, fish-shaped hunters ammonites, spiral-shelled relatives of squids. Oceans weren't peaceful. They were battlegrounds. And no matter how strange dinosaurs got on land, there was always something stranger below the waves. Enter the Cretaceous period. Fast forward to around 145 million years ago. Welcome to the Cretaceous, the final act of the dinosaur saga. The climate is still warm. Continents have drifted even farther apart. New plants are spreading. And the dinosaurs? They're going global. Flower power and buzzing insects. In the Cretaceous, something beautiful happens, flowers appear. Before this, plants reproduced using spores or cones. But now, flowering plants show up, fast, efficient, and colorful. They attract early insects, bees, butterflies, beetles. Pollination becomes a thing, and the landscape changes forever. Grass isn't around yet. But with flowers and shrubs, plant life is evolving rapidly, and that means new food for herbivores. The rise of iconic dinosaurs. Here come the celebrities. Cretaceous dino legends include sauropod Triceratops, 3 horns. Giant frill. Built like a tank. T-Rex Tyrannosaurus rex, 40 feet long. Banana-sized teeth. The goat of predators. Sauropod Ankylosaurus, armored body. Club tail. Basically a living tank. T-Rex Velociraptor, smaller than in the movies. Feathered. Smart. Sharp-clawed. Sauropod Spinosaurus, crocodile snout. Loved water, had a giant sail on its back. By now, dinosaurs had taken over every role: grazers, hunters, swimmers, flyers, runners, thinkers. They came in every size, color, and shape you can imagine. Wait, dinosaurs had feathers? Yes. Many of them did. Especially the smaller theropods. Feathers likely started as insulation, then became tools for display, camouflage, and eventually, flight. Some dinosaurs even glided from tree to tree. And over millions of years, one group of feathered dinosaurs became birds. So yeah, birds are literally modern dinosaurs. That pigeon outside your window? It's a tiny, judgmental dino. Mammals in the shadows. Meanwhile, our ancestors were around. Tiny, furry, nocturnal mammals scurried under logs and in burrows. They were small, quick, good at hiding, great at surviving, no threat to dinosaurs. But when the time came, they'd be ready. And then, the sky falls. The Cretaceous is wrapping up. Everything is lush. Loud. Alive. Then, around 66 million years ago, it happens. A 6-mile-wide asteroid slams into what is now the Yucatan Peninsula in Mexico. The explosion is unimaginable. Fires across the planet, earthquakes, tsunamis, months of darkness, global cooling. It's not just a bad day. It's the end of an era. Extinction level event. In the aftermath, 75% of all species go extinct. All non-avian dinosaurs are wiped out. Pterosaurs vanish. Marine reptiles disappear. Only small, adaptable creatures survive. The age of dinosaurs is over. But something is waiting in the shadows. Mammals. And their time has finally come. Why this chapter matters: this is the peak of prehistoric life. Dinosaurs dominated every part of Earth, land, sea, and sky. They were fast, fierce, smart, diverse, beautiful, and yet, it only took one rock from space to end it all. Life isn't about power. It's about adaptation, survival, change. And the next age? It's about to look a lot like us. Close your eyes, and let the earth roar. Hear the jungle. The buzzing insects. The calls of massive beasts in the trees and plains. Bird-like dinosaurs chirp. Triceratops thunders through underbrush. T-Rex lets out a final roar. Then, silence. Dust covers the sky. But beneath it all, in a small hole in the ground, a little mammal twitches its nose. The future just changed. The Cretaceous world is buzzing with life. Dinosaurs rule the land. Pterosaurs glide above. Marine reptiles hunt the seas. Birds sing from flowering trees. Insects pollinate. Mammals hide. It's a masterpiece, the most alive Earth has ever been. And then, in the middle of all this beauty, the sky falls. One rock to end an era. The time is 66 million years ago. Far out in space, a chunk of rock is drifting. Not just any rock, a massive, 6-mile-wide asteroid, moving at over 65,000 kilometers per hour. It's on a collision course with Earth. There are no telescopes, no scientists, no warning. Just a bright spot growing in the sky, until it becomes a fireball. And then, impact. Chicxulub, ground zero. The asteroid hits near what is now the Yucatan Peninsula in Mexico. The place is now called the Chicxulub crater, a scar left from one of the most violent days in Earth's history. Let's break down what happened in the first few minutes. The asteroid slams into Earth with the force of 10 billion Hiroshima bombs. It punches a hole 100 miles wide, vaporizing rock instantly. Temperatures at ground zero spike to thousands of degrees. Everything nearby, gone in an instant. Shock waves ripple across the planet. Earth shudders. But that's just the beginning. Fire from the sky, debris from the impact flies high into the atmosphere, bits of rock, dust, glass, and vaporized earth. Then, it falls back down. But it doesn't float gently. It burns. As trillions of particles re-enter the atmosphere, they superheat the sky. For hours, or even days, fire rains down across the globe. Forests ignite. Grasslands turn to flame. Smoke chokes the air. It's not just a meteor strike. It's a planet-wide firestorm. Darkness falls. Next comes the dust. Billions of tons of ash, soot, and particles rise into the sky. It forms a thick layer in the atmosphere, blocking out the sun. And when sunlight disappears, temperatures plummet. Photosynthesis stops. Plants die. Food chains collapse. This isn't just climate change. It's climate shutdown. The warm, thriving Cretaceous world becomes cold, gray, and silent. Death ripples across the planet within weeks. The world looks completely different. Skies are dark. Fires rage. Oceans become acidic. Rain turns toxic. Earthquakes and tsunamis tear through coastlines. And across it all, the dinosaurs begin to vanish. Not just the big ones. All non-avian dinosaurs. Tyrannosaurus. Triceratops. Ankylosaurus. Velociraptors. Gone. So are pterosaurs, ammonites, mosasaurs, giant marine reptiles. Insects suffer. Plants die. Even tiny plankton in the ocean collapse. The extinction reaches every corner of the Earth. 75% of life, gone. It's one of the big 5 mass extinctions, and one of the most famous. Scientists estimate that 3 out of every 4 species on Earth went extinct. Entire ecosystems collapsed. It was the end of the Mesozoic era. The end of the age of dinosaurs. But not the end of the story. The survivors, a few species make it through. Birds, the only dinosaurs to survive. Small mammals, especially burrowers, crocodiles, they go way back and somehow keep going. Turtles, snakes, frogs, low-energy survivors, insects, resilient little things, plants with hardy seeds, ready to regrow. These weren't the strongest. They weren't the biggest. They were the most adaptable. The age of giants was over. Now, it was time for the clever, the quiet, the small. Chicxulub's legacy. For a long time, we didn't know this event even happened. The crater was hidden, buried under layers of sediment and water. But in the 1970s and 80s, scientists found a global layer of iridium, a rare element linked to asteroids, shocked quartz and glass beads, signs of high-energy impact. A massive crater under the Yucatan Peninsula. The evidence was clear. Something hit us hard. And it changed everything. What if it never hit? It's one of history's biggest what-ifs. If the asteroid had missed Earth by just minutes, dinosaurs might still rule today. No mammals. No humans. No smartphones. No bedtime stories. Instead, just big, scaly, feathered creatures roaming the continents. But fate had other plans. And one violent day reset the planet forever. From ashes to opportunity. As the smoke cleared, the survivors emerged. Tiny mammals began to rise. They evolved. Spread. Multiplied. They explored every niche the dinosaurs left behind. And one day, millions of years later, they stood upright. Spoke. Built cities. Sent rockets into space. You, me, everyone you've ever known, we all exist because of that one asteroid. From destruction came destiny. Close your eyes, and remember, picture it. The final day of the dinosaurs. A sunny morning. Birds chirp. Giant beasts graze. Then, a flash. A roar. A wall of heat. And silence. Later, the wind blows through scorched trees. The sky stays dark. The earth waits. And deep underground, in a burrow, a tiny, shivering mammal curls tighter in the dark. It doesn't know what just happened. But it survived. And that was enough. The dinosaurs are gone. The skies are dark. The world is still. But beneath the silence, there's movement. Tiny paws, fur brushing against leaves. A quiet sniff in the dark. The age of dinosaurs has ended. Now begins the age of mammals. And nothing will ever be the same again. Picking up the pieces. It's just after the asteroid impact, about 66 million years ago. The planet is healing. Skies are slowly clearing. Ash settles. Forests begin to regrow. The big creatures are gone. But small ones? They're still here. Tiny mammals, rat-sized, burrow-dwelling, wide-eyed survivors, they made it through the fire. Why? Because they were small, easier to hide, warm-blooded. They could handle cold nights. Burrowers, safe from the heat, the dark, and the chaos. Flexible eaters, they could chew roots, bugs, whatever was left. They didn't win by being strong. They won by being smart. Mammals were always here. Just hiding. Let's be clear, mammals didn't just show up after the asteroid. They were around during the time of dinosaurs too. But they were background characters. Night shift workers. Tiny, quiet, overlooked. But now, with the giants gone, they finally had the spotlight. And they were ready. The great mammal expansion. Over the next few million years, mammals exploded in diversity. They filled every gap the dinosaurs left behind. Small insect eaters became moles and shrews. Tree climbers evolved into monkeys. Water-loving mammals gave rise to whales. Grazers turned into deer, horses, and elephants. Hunters evolved into cats, dogs, and bears. They got bigger, smarter, faster. And they spread across jungles, deserts, plains, and mountains. Earth was theirs now. Why? Mammals were built for this. Mammals had some key upgrades: big brains. More neurons. Better memory. Complex behavior. Problem solving. Red heart, warm blood. They could survive in colder places. They didn't need the sun to stay active. Baby bottle milk and parental care. They didn't just lay eggs and leave. They protected their young. Nurtured them. Passed on survival skills. Headphone-sensitive hearing and smell. Useful in the dark. Helpful for finding food and avoiding predators. Paw prints, flexible limbs and body shapes. They could climb, swim, dig, run. Mammals weren't the fastest at evolving. But they were the most versatile. The Earth evolves too. While mammals were growing, so was the planet. Continents kept drifting into their modern places. Climate zones shifted. Mountains rose. Rainforests spread. And grass, yes, grass, started to take over. The first true grasslands appeared during this time. And that changed the game. Animals adapted, hooves for running, long legs for speed, flat teeth for grinding grass. This was the birth of herds, big, moving groups of grazers like antelope and buffalo. And behind them? Predators. Enter the apex hunters. With more herbivores, came better hunters. Cats evolved sharp claws and silent steps. Canines formed packs and chased in teams. Bears grew strong and adaptable. But one group stood out. They didn't have the biggest teeth. Or the fastest legs. But they had brains. Gripping hands. Curiosity. They were the primates. The rise of the primates. Primates evolved in the trees, grasping fingers, forward-facing eyes. Strong memory. Social bonding. They started small, squirrel-sized, swinging through ancient forests. Then some got bigger. More intelligent. More social. They formed families. Tribes. Learned from each other. Among them, a group called hominids began to branch off. And eventually, humans would arrive. But that's one chapter ahead. The mammal kings of the past. Let's pause and meet a few prehistoric celebrities from this era: mammoths, giant woolly relatives of elephants. Giant bison, twice the size of modern ones. Tiger-faced saber-toothed cats, massive predators with knife-like teeth. Hippopotamus, giant ground sloths, slow-moving, tree-toppling beasts. Elephant Indracotherium, the largest land mammal to ever live, like a rhino on stilts. These were Earth's new giants. Not cold-blooded reptiles. But warm-blooded, furry titans. Nature had started over, and mammals were writing the new rules. Not all sunshine and grasslands. Of course, it wasn't smooth sailing. Earth faced more climate changes, ice ages. Volcanic winters. Dry spells. Sea level shifts. Some mammals went extinct. Others shrank, moved, or adapted. But unlike the dinosaurs, mammals could change fast. They migrated. They stored fat. They developed fur, tusks, and tools. They endured. Why this chapter matters. This isn't just the rise of mammals. It's the prequel to us. Every big leap, caring for young. Thinking ahead. Working together. Exploring new places. It's all here. Mammals didn't just fill the world. They shaped it. And in one forest, somewhere in Africa, something amazing was about to happen. A new kind of mammal would walk upright. Think deeper. Change everything. But that's for the next, and final, chapter. Close your eyes, and hear it. The forest is dense. Birds chirp. Leaves rustle. A herd of mammoths trudges through snow. A pride of saber-toothed cats waits in the tall grass. A family of primates plays in the trees, watching, learning. The giants of the past may be gone. But the world is more alive than ever. And soon, it will start dreaming. We've traveled billions of years. Through fire and ice. Explosions and extinctions. From single cells, to forests of giants, to woolly beasts and saber-toothed hunters. Now, in this final chapter, something new walks the earth. You. Me. Us. This is the story of Homo sapiens. Our species. The latest chapter in Earth's long and wild book. Let's begin. A new kind of animal. The time is around 300,000 years ago. Somewhere in Africa, a creature is born. It looks similar to others, but something's different. Its skull is rounder. Its brain is larger. Its hands, more precise. Its eyes, more curious. This is Homo sapiens. And it will go on to redraw the map of Earth. Where we came from. We weren't the first humans, not even close. Before us came Australopithecus, early upright walkers. Homo habilis, tool users. Homo erectus, travelers and fire makers. Neanderthals, strong, smart, and social. Denisovans, our mysterious cousins. But we, Homo sapiens, had something extra. Not just tools. Not just fire. But language. Imagination. And the ability to work together in large groups. We weren't the fastest. Or the strongest. But we were the best at sharing ideas. And that made all the difference. The Great Expansion. For the first few thousand years, we stayed close to home, mostly in Africa. Then something changed. We began to spread into the Middle East. Across Europe. Through Asia. Down into Australia. Up into Siberia. Across the Bering Land Bridge into the Americas. We walked across deserts. Built rafts for oceans. Survived snow, drought, predators, and each other. And wherever we went, we adapted. We became Inuit in the Arctic. Aboriginals in the outback. Nomads on the plains. Farmers in river valleys. Sailors on distant islands. Different climates, different diets, different skin tones. But all still one species, Homo sapiens. What made us different? We weren't just survivors. We were creators. We made spears and traps to hunt. Clothes to shield us from cold. Shelters to keep us dry. Paintings on cave walls. Music from bones and strings. Stories whispered around firelight. We began asking questions. Inventing gods. Dreaming of futures. We didn't just react to the world. We began to shape it. Agriculture, the big shift. Around 12,000 years ago, we did something no other species had ever done. We stopped moving. We planted seeds. This was the birth of agriculture, and it changed everything. With farming came villages. Then towns. Then cities. Trade, writing, government, money, religion. We domesticated wheat in the Middle East, rice in Asia. Maize in the Americas. Cattle, sheep, and dogs all over the world. We weren't just surviving anymore. We were building civilizations. But not without cost. This new life had consequences. Farming meant harder labor and poorer diets. It caused population booms, and then conflict. Humans began to compete for land. Wage wars. Build empires. Enslave each other. Rewrite landscapes with axes and fire. We cut down forests. Drained swamps. Caged animals. Tamed rivers. And for the first time, we changed the earth more than earth changed us. The rise of civilization. Fast forward to just the last 5,000 years, a blink on Earth's timeline. We built the pyramids of Egypt. The Great Wall of China. Stonehenge in Britain. The cities of the Maya, the temples of India, the forums of Rome. We invented writing. Math. Medicine. Philosophy. Democracy. Electricity. The Internet. We traveled to the deepest oceans. Then to the moon. Now we aim for Mars. All in the blink of a cosmic eye. The planet feels it. But our rise hasn't been gentle. In just a few centuries, we've burned through fossil fuels, raised CO2 levels, melted glaciers, damaged ecosystems, caused extinctions, shifted climate patterns. We now live in a time some call the Anthropocene, the age where humans are the most powerful force on the planet. And Earth is watching. So, now what? Here we are. The latest chapter in a 4.5 billion year story. We're building AI, exploring space, healing diseases, streaming bedtime history stories, thanks to you, boss. But we're also facing climate crises, losing biodiversity, dividing ourselves, forgetting the big picture. The truth? We're still writing this chapter. And the ending? It's up to us. Why this chapter matters most. Every chapter before this one. From molten lava to snowball Earth, from trilobites to T-Rex. Led to you. You are the product of every survivor, every adaptation, every second of cosmic luck. The atoms in your body were once in stars. The air you breathe was shaped by ancient microbes. The ground beneath you was once molten fire. You're not separate from Earth's story. You are Earth's story. Close your eyes, and listen. Outside, the wind blows through trees that grew from soil made by ancient forests. The stars above you are the same stars early humans painted on cave walls. The breath you take is the same air dinosaurs once inhaled. The story isn't over. You're part of it now. Thanks for watching. Don't forget to subscribe.